All right, let's get into something really cool. Building a powerful AI that runs entirely on your own hardware, using your own private data. We're talking about a system where you are in complete control. It's secure, it's up to date with your information, and it's all yours. But first, we have to talk about the big problem. You've probably seen this, right? Why do these incredibly smart AIs sometimes just make stuff up? A super powerful large language model, an LLM, will state something with complete confidence, but it's totally wrong. It's a phenomenon called hallucination, and it's the single biggest problem we've got to tackle. So what's really going on here? Well, it all comes down to the fact that an LLM's knowledge is basically frozen in time. This is its parametric memory. Just think about it like this. The AI does all of its learning during this massive training phase, but the second that training stops, its knowledge base is locked. It's like a genius who graduated and then never read a book or an article ever again. It's totally blind to new information, and more importantly, it's blind to your private data. So what's the fix? How do we bridge that gap between the AI's static, frozen brain and the real, live, dynamic world? Well, the solution is actually pretty clever. We basically give the AI a second brain, an external, live knowledge source it can check in with anytime it needs to, one that's grounded in your specific, up-to-the-minute facts. And this is where the magic happens. It's a technique called Retrieval Augmented Generation, or RAG for short. It's a total game changer. You can think of it as giving the AI a new superpower, the ability to do a quick search before it speaks. So before it even tries to answer your question, it does some real-time research in a private library that you control. Okay, so how do we actually build this thing? It's not some black box. It's a really well-defined engineering process, a 5-stage blueprint that takes your messy, raw data and turns it into clean, useful context that the AI can understand. And here are those 5 stages. It all starts with loading your data. Could be PDFs, text files, notes, you name it. Then comes the really important part, indexing. This is where you create a special kind of map of your data, one based on its meaning, not just keywords. From there, you store that map so it's ready to use. Now, when you ask a question, the system queries that index to find the perfect snippets of information. And finally, that perfect little package of info is handed off to the LLM for the generation stage, where it crafts a smart, factual answer. All right, that's the theory. Now let's get our hands dirty. How do you actually build this on your own machine? See, running everything locally gives you all the power, but it also means you've got to think about hardware. And when it comes to local AI, there's one thing that rules them all. Yep, VRAM is king. Everything, and I mean everything, comes down to your GPU's video memory. It's the ultimate bottleneck. The amount of VRAM you have directly controls what size model you can run and how fast it's going to be. It's the one thing you absolutely have to plan for. And take a look at this. This really drives the point home. Even a so-called small 7 billion parameter model can chew through 16 gigs of VRAM. So how do we even get these things to run on our home machines? The answer is a brilliant trick called quantization. You can think of it as a way to put the model on a diet, shrinking its memory footprint so it can actually fit on a regular graphics card. Now, thankfully, you don't need a PhD in GPU programming to do this. There's this amazing tool called Allama, and it's basically become the go-to for running models locally and for good reason. It just handles all that nasty, complex setup for you, giving you access to the AI through a simple, clean API. Okay, next up, you need somewhere to store that meaning map we talked about. That's your vector store. And this is your first big choice. It's kind of like, do you want the easy-to-use, all-in-one appliance? That's ChromaDB. Or do you want the high-performance manual transmission power tool? That's Face. All right, so a basic setup will get you surprisingly far. But if you want really good production-level results, we need to level up. And that means tackling a really tricky balancing act in how we get our data ready. Here's the problem. To find the exact right piece of information, you want to search through tiny, specific chunks of text. But for the AI to give you a great, well-thought-out answer, it needs the bigger picture, the full context of a larger paragraph. So you're stuck, right? Do you go for small and precise or big and contextual? Well, turns out we can have it both ways. The solution is a really smart technique called parent document retrieval. Here's how it works. You search through the small, precise child chunks to find that perfect needle in the haystack. But then, once you find it, you use it as a pointer to go and grab the whole parent document it came from. So you get pinpoint accuracy and full context. It's brilliant.
But wait, there's another problem. What if you're searching for a specific product name, like Model XJ5000? A search based on pure meaning, what we call dense retrieval, might actually miss that. It's looking for concepts, not exact phrases. That's why the pros use something called hybrid search. You run your fancy meaning-based search, and you run a good old-fashioned keyword search at the same time.
Okay, so now you've got two different search result lists. How do you merge them into one great list? You use an algorithm called reciprocal rank fusion, or RRF, and it's simpler than it sounds. It basically just says, hey, I don't care about some weird relevance score. I only care about the rank. If a document is number 1 on the keyword list and number 3 on the meaning list, it's probably really important. It's a super effective way to combine the best of both worlds. So, with this hybrid approach, we cast a really wide net. We're telling the system, just bring me back everything that might even possibly be useful. So you might end up with, let's say, 50 different documents. Now, obviously, we can't just dump all 50 of those on the LLM. That would be slow, and a lot of it would just be noise. So we add one last, crucial step, re-ranking. Think of it like a specialist librarian who takes that big pile of 50 books and with an expert eye picks out the absolute best 5 you actually need to read. And this is just a massive win-win. Your answers get way more accurate because you've cut out all the junk, and your system gets way faster because the LLM has so much less work to do. For a local setup running on your own GPU, that is absolutely huge. All right, let's put this all together. What does the complete pro-level stack actually look like? This is the whole shebang, from start to finish. So here it is, the 3-part recipe for success. 1. Parent document retrieval, for that perfect balance of detail and context. 2. Hybrid search with RRF, to make sure you find everything relevant. And 3. A re-ranker on top to give you that final polish of precision and speed. But remember, and this is a golden rule, you can't improve what you don't measure. Once you've built all this, you have to test it. And you're basically asking 2 big questions. First, groundedness. Is the AI sticking to the script? Is it actually using the facts we gave it? And second, relevance. Is the answer actually, helpful? Does it solve the user's problem? You have to track these metrics. So look, this isn't just some academic theory. This is a real-world blueprint. It's how you build a powerful private AI that you control, using your data. The tools are here, the techniques are clear. The only real question left is, what are you going to build with it?